Now these reactions given over here is again the uh, revision of reactions and conversion discussed in the chapter number 9, how different functional group are converted from one into another. A compound given over here is the alkyne, how alkyne is changed into different functional group, into acetone, into aldehyde, into carboxylic acid, how halogen is bring out, how alkyne change into alkene. So different functional groups changed. In chapter 9 we have discussed all these transformations. If we know these transformations, then these functional groups transformation will be easy, organic synthesis will be easy. So this chapter 11 organic synthesis will be easy if we have a concept about chapter 8 and chapter 9 so far we have discussed. Because next topic is the functional group transformation, FGT, functional group transformations, how functional group transformed. So that is the main task, and how this task we will fulfill this task. So if we have a background about the conversions, then definitely we will do that reactions and conversion easily. Otherwise uh, we have in trouble to do a synthesis. uh, Alkyl halide is given. This is alkyl halide. If alkyl halide is given and we want to do elimination reactions, alkene will be our product. And again, if we add halogens on this alkene, so alkyl halide again will be obtained. So main target molecule is, suppose we have given this alkyl halide and we have asked convert into another alkyl halide. So what is the difference between this first alkyl halide and the second alkyl halide? Just I have number first and second. So what is the difference between the first alkyl halide and second alkyl halide? Difference is just change in position, regiochemical positions, just change in bromine positions. So how bromine change its positions? This is a strategy. This is our target molecules. Number 2 is our target molecules. So target molecule is number 2. We have to synthesize number 2 compound from number 1 compound. So how number 1 compound is changed into number 2 compound, how target molecule is synthesized? Just bromine change its positions, regiochemical position change. It will not be very easy to uh, bring these positions, break this bond and add on this position. It is not very easy. So we have to think about this conversion, and we have to make a strategy about this conversion. Strategy is that first of all, this alkyl halide is convert into alkene, and we have discussed and we have studies in previous chapter how this alkyl halide change into alkene. When this alkyl halide change into alkene, this is a satisfied product. Alkene for here synthesized in substituted alkene. So whenever we want to bring out a reaction of alkyl halide to a substituted alkene, or we want to do a satisfied product, then we have to keep in mind reagents for a satisfied product. When this substitute alkene is formed, then again this substitute alkene change into alkyl halide. Again we have to add bromine on the on the carbon which have substituents, means negative part of the halogen add on that carbon having less number of hydrogens. So when alkene convert into alkyl halide, we have to keep in mind two rule: Markovnikov addition or anti-Markovnikov additions. If we have know about Markovnikov's additions, yes, we know the conditions and reagent for Markovnikov additions, and what will be the result for that Markovnikov additions. And we must also know anti-Markovnikov addition reagent and its result. If we know that these conditions, yes, we can do that change. We can bring that change. We can transform alkene into alkyl halide. That will be easy. So strategy must be in mind, different reagents must be in mind, different routes can be adopted, so target molecule can be synthesized. So this strategy here given alkyl halide. So alkyl halide change into alkene. So alkyl halide change into alkene. How this alkene is made? By reacting sodium ethoxide reagents. So substitute alkene here made by, we can say that is a satisfied product. So HBr is now added over this alkene. Through Markovnikov addition, Br will add on that carbon having less number of hydrogens. So target molecule which was given to us, now we are able to make this target molecule just following this strategy. This is a strategy design. Root over here is this. So you can do or you can apply this route. Just I mentioned over the first route. So you can adopt number one route, but you can do and you can adopt another route as well. Which route? If we want to bring this route, so if we want to bring this route give target molecule or not. Suppose this alkyl halide treat with tertiary butoxide ion, then alkene will be unsubstituted Hoffman product. So if we add HBr, anti-Markovnikov combinations, so alkyl halide will be that. So our target molecule was this, but we have made alkyl halide this. So it is not our desired target molecules. So target molecule we just have to synthesize this, and now this alkyl halide is made. So it is not our target molecules. It means this is not a required or design strategy. So we will ignore this strategy. Yes, we follow this strategy if target molecule is given. If we have to ask this is our target molecule, this is our target molecule, yes, then we can follow this route. If we have to ask target molecule is this, then we will follow route number 2. So there are different strategy design for the synthesis. You have to remember all the design strategy, reagents and routes, and what are the conversion of how different functional group convert, functional group interconversions must be known, and reagent must be known, so that organic synthesis will be very easy. If we don't have any idea about the reagents and we don't have any idea about the strategy to bring out the conversions, then it will be very difficult and maybe we will be in trouble to bring out this change. Some functional group changed are very difficult, as reactions given over here is the OH functional group. So this OH functional group, sometime directly it is very impossible to bring out OH group. How OH group is, uh, how can we do this OH group on this carbon? So first of all, change this OH group into OTS, tosyl. This is a good living group. So make OH group as a good living group. Now this strategy is inverted strategy. Inverted strategy means you have to ask to convert this compound into this compound. If we have to convert this compound to this compound, it means only change in OH group is only just OH group is changed its positions. Again, it is a regiochemical change. So it will not be very easy to bring the OH position from number 2 to number 1 positions. So it looks like very easy, but it is not very easy. So first of all, we have to replace this OH group into good living group. Otherwise, OH is not a good living group. OH is a bad living group. So tosyl group is a good living group. Change OH group into OTS. Then do elimination reactions. Elimination reactions mean or this good living group will leave and double bond will be formed, and this is through E2 reactions. E2 reactions, okay, E2 reactions we have alkene. Then we add OH group. How OH group is added on the double bond? There are number of the reactions, variety of reactions we can add OH group. So we have to keep in mind reagent for addition of OH group. If we know the reagent for addition of OH group, then that will be easy to make this target molecule OH group. So we can bring a regiochemical change, and we can change position of OH group. So this is the designed strategy how we can convert this particular functional group position to the other molecule or other compound having the change in position of the OH group. This is a strategy. So this strategy can be adopted in number of different routes, a number of different design strategy. So just we here focus the design strategy to bring out the change this particular compound into this compound. So this OH group first change into uh, eliminations. Even if we do even reaction, elimination unimolecular reactions, then alcohol can be changed into alkene. When alcohol change into alkene, then add we have to add OH group. Add OH group means maybe addition of water in the presence of acid. When we add water in the presence of acid, H2SO4, HgSO4, water, then through Markovnikov additions, water, OH part of the water add on that carbon having a less number of hydrogen or no hydrogen. So definitely OH will add on the this carbon, tertiary carbons. This product will be obtained. So we have to convert secondary alcohol into tertiary alcohol. Position of OH is changed. So how position of OH is changed? Just designing the strategy and following these steps. So change of location of the OH group. So one strategy was change of location of the OH group, was that having only two steps. So other design routes are given over here. So OH position is changed from secondary to tertiary, as mentioned in the route number one, first route. Uh, Other routes are given over here. How secondary alcohol change into tertiary alcohol. Number one, number one route is that the secondary alcohol first change into good leaving group. OH OH first change into good leaving group means tosyl group. So when you have to change tosyl group, then follow uh, then that group E2 then follow E2 reactions. E2 reactions definitely give alkene, and alkene when we have alkene, just add water in the presence of acid. So water added through Markovnikov additions. Then we have to tertiary alcohol. OH group change its position from secondary to tertiary carbon. But another strategy is that if we want to bring change, if we want to change position of OH from secondary to primary carbon, it means we want to prepare primary alcohol from secondary alcohol. One strategy was we want to prepare tertiary alcohol from the secondary, and then we will follow route 1 and this route. And if we want to convert secondary alcohol OH on the secondary carbon to primary, then which route we will follow? We will follow many routes. One of them is this one of the route is that now we want to convert secondary alcohol into primary alcohol. So we have alkene, this alkene, treat it with BH3 tetrahydrofuran, water, and H2O2 and NOH. It gives the secondary alcohol. Secondary alcohol means when treated with BH3 tetrahydrofuran and hydrogen peroxide, OH always add on the less substituted site. OH always add from less substituted site. This is the difference. We can say this is anti-Markovnikov additions. This is anti-Markovnikov additions. Always keep in mind, if you want to add OH group from less substituted site, then select this reagent BH3 tetrahydrofuran iron peroxide and NOH. And if you treat water in the presence of acidic media, then OH will add through Markovnikov additions, and Markovnikov additions mean OH negative will add on that carbon having less hydrogen or no hydrogen, then tertiary alcohol is formed. So this alkene can give again secondary alcohol by anti-Markovnikov additions and give tertiary alcohol through Markovnikov addition. These are the routes. And if this secondary alcohol change into primary alcohol, then follow these route. Convert OH into good leaving group to silyl group, and follow then treat with tertiary butoxide ion. Tertiary butoxide ion means follow E1 mechanism. It gives unsubstituted alkene, and unsubstituted alkene again if treat with uh, BH3 tetrahydrofuran, definitely there is alkene. So these reagents are for the anti-Markovnikov reagents. BH3 tetrahydrofuran peroxide and NOH reagent for anti-Markovnikov addition. It means now OH will add OH will add on that carbon, having less substitution. So we can make the primary alcohol from secondary alcohol. So we can synthesize primary alcohol from secondary alcohol. We can synthesize tertiary alcohol from the secondary alcohol. So there are varieties of reactions. So varieties of reactions can do. Just we have reagent concept, and we have a strategy, design strategies. If we have a design strategy and we have a reagents, then we can do a reactions. We can convert one functional group into another. We can change location of a functional group from one position to another position. So change in locations, regiochemical change, functional group transformation will be very easy if we know the route and design strategy. This alkene now change into this alkene. This is a substitute alkene, and this is unsubstituted alkene. How this substitute alkene converted into unsubstituted alkene? Means question may be asked, convert this into directly this alkene converted into, question may be asked like this, convert this compound into this compound. So we have to design strategy how position of double bond is changed. So far we have discussed position of bromine and position of OH. Now position of double bond is changed. How position of double bond, position of functional group can be changed? We have to design a strategy. We have to convert and change position of particular functional group. So strategy, design strategy given over here. So first of all, change alkene, uh, given alkene into alkyl halide. First of all, change given alkene into alkyl halide. We have alkene and we add HBr. If we add HBr through Markovnikov additions, Markovnikov additions means we will add Br negative to the carbon having less hydrogen. So product will be this. It means we have now tertiary alkyl halide, Br on the tertiary carbon. So whenever halogens at the tertiary carbon and we have a tertiary butoxide ion, this is a base, bulky base. So bulky base, again in a previous reaction we also treat bulky base. So bulky base always give unsubstituted alkene. This tertiary butoxide ion always give unsubstituted alkene. So treat this alkyl halide with tertiary butoxide and will give unsubstituted alkene. It means we have to convert position of double bond from substitution to unsubstitution. This was our required product. So we have made a strategy. Design strategy is this. This is the route. So we will follow that route. When we follow the route, we must keep in mind the reagents, and we must also know a reaction is possible or not, and we must know the feasibility of reaction, and we must know a cost of reactions, whether we have selected costly reagent, expensive reagent, or we have a inexpensive and reagents. So normally in synthetic point of view, reaction is chosen which have inexpensive reagents. So this tertiary alkyl halide, halogens on tertiary carbon, can change into substituted alkene when treated with sodium ethoxide. This is not a bulky base. Bulky base when treated always give unsubstituted. So this is small base, so it gives substituted. Again, this is a secondary alkyl halide. When secondary alkyl halide treat with sodium ethoxide, and it again gives substituted alkene. And if we want to add this alkene through anti-Markovnikov additions, HBr peroxide, then Br will add from less substituted side. So anti-Markovnikov additions give less substituted side. Now Br is at the secondary carbon. If we add HBr through Markovnikov addition, it gives a tertiary alkyl halide. And now we add HBr through peroxide and anti-Markovnikov addition gives secondary alkyl halide. Again, we treat this secondary alkyl halide with tertiary butoxide ion. It gives this product. So there are varieties of routes and organic synthetic reagents available. Just we have to keep in mind which route is suitable for our target molecule and which is not suitable for our target molecules. So question here, one question is to convert position of one question was to convert this alkene into this, and maybe uh, we can say to convert this alkene into this directly. Question may be asked, and question may be asked, convert this alkene into this. So in both strategies, in both design strategy, position of double bond is changed. Position of double bond changed. Position of double bond was present inside the ring and now outside the ring. Position of double bond present at the substituted side and now on the unsubstituted side, but present within the ring. So whatever the conditions required to bring out the target molecules, we have to design the strategy. Suppose I assigned number 1 for this strategy and number 2 for this strategy. If we want to convert double bond outside the ring, then we will follow strategy route 1. And if we want to convert double bond positions, double bond will remain inside the ring. Double bond will remain inside the ring but change its position, then we will follow route number 2. So this is a strategy design in organic synthesis. Again, cycloalkane is given. Cycloalkane. This is a cycloalkane. Substitute cycloalkane. Change this cycloalkane into cycloalkene. So how cycloalkane directly change into cycloalkene? Treat it with halogens, radical brominations. We know that whenever we want to bring halogen on the tertiary carbon, always do bromination, radical bromination. It is a rule, hard and fast rule. In our previous chapter, we have discussed when we want to bring brominations at tertiary carbon, do radical bromination. Do radical bromination. Always do radical bromination. If you want to do chlorinations, that will be thermodynamic unfavorable, and your reaction will be wrong. Your reaction will be right when you do radical brominations. Yes, now bromine at the tertiary carbon. Just eliminations. substituted alkene, that is a product. It means we will do eliminations, our required product will be obtained. Alkyne, now alkyne is given, and we have to ask convert this alkyne into alkene. How alkyne change into alkene, we have discussed and studied this conversion in the previous chapter might be chapter 8. So how alkyne change into alkene, uh, we must have the idea about the catalyst, Lindler catalyst. Yes, if again hydrogenation, we alkene can be changed into alkane. So varieties of reactions may be given, and we have to ask synthesize particular functional group. I think this organic synthesis is just a revision of the previous chapters. Just revision of the previous chapters. If we have a concept about the previous chapters, then this synthesis is very easy. Propose an efficient synthesis for the following transformation. This is our target molecule. Convert this into this. Convert this alkene into alkyl halide. Convert this alkene into alkyl halide. It means uh, we have to keep in mind what are the functional group positions. Just we have to focus position of functional group. In reactant side alkene, position of the functional group was the double bond, and double bond was present at carbon 2 and carbon 3, C2 and C3. In between C2 and C3 double bond was present. And alkyl halide, when alkyl halide is made in a product, then this alkyl halide having the functional group at carbon number 1. So carbon number 1, now functional group is carbon number C1. So we have to bring from functional group 2 and 3 side to first carbon. So we have to bring change from functional group 2 and 3 to first carbon. How this strategy, uh, which strategy design will work, how we can do the strategy. So when we want to bring a strategy, always keep in mind we will go reverse. We have to ask convert this into this. When we have to ask convert this into this, means we have given target molecules. Always pick your target molecules. Yes, we have chosen a target molecules, and go reverse manners. Always pick your target molecule. Yes, we have chosen target molecule, and go reverse. How we will go reverse? If we have this alkyl halide and we want to bring a change, or we want to bring an elimination reactions, so when we go reverse, we always write arrow in such a manner. This is arrow for go through a reverse reactions. Reverse reactions mean we are breaking down. Just simply is that if you have any furniture like bed, sofa or chairs, okay, and you have to ask to change these chairs, bed and sofa into its fragments, then what you can do? You can do a fragment. You will break down. Definitely you will break down and do a fragments. And then you have to ask now, combine these fragments together, and then redesign your chairs and sofa and our bed. So it is just like that. You have given a target molecule and asked to break down a fragment, and then when you have break down a simple fragment, then you have to ask now join these fragments. So this is your strategy. Target molecule is given, so now you are going to break down this target molecule into fragments. So first you have to convert this alkyl halide into alkene. So when you go reverse, sometime term is used retrosynthetic. Retrosynthetic analysis mean you are going reverse. So when you are going to reverse, then you will write this arrow like this. So alkyl halide now change into alkene. So you can also bring a change. You can convert alkene into again alkyl halide. So what is difference? Alkyl halide change into alkene and alkene into alkyl halide. Difference is that you have changed position of alkyl halide. You have changed position alkyl halide. Halogen was present at the end of the chain. Now halogen is present on the second carbon. So if you want to bring a change from the first carbon to second carbon, then you have to go through these steps alkene. You have to go through this step alkene. Then you can do a change from the halogen from first carbon to second carbon. But this is not an end. This is not an end fragment. This is not end fragment. Again, this alkyl halide change into alkene. So which process here done? It means it is elimination. Which type of elimination and which type of product? It is a substitutive product because it is a substituted alkene. And for a substitutive product and substitute alkene, which type of reagent we used? Sodium ethoxide used. So whenever sodium ethoxide is used, always substitute alkene is. So we have to go reverse. Now this alkene is available. So this alkene, which is substitute alkene, is available. Now you have changed your fragments. You have made your fragments starting from target molecule. This was your target molecule, and you have made fragment of target molecule. First fragment was this, second fragment was this, and last fragment was this. As I mentioned, when you have a target molecule and you have made fragment for target molecule, so start from the last fragment. You will start reaction from the last fragment, and your last fragment was this was your last fragment. So choose this fragment. Yes, this is, we have chosen this fragment. So now your route will be, when you are doing retrosynthetic, your route was this. Now you are synthesizing, so your route will be on these directions. Okay, so your route will be from that direction, opposite directions. So you will choose last fragment. Yes, we have chosen last fragment. Now bring a change. Anti-Morconi additions, HBr peroxide. So when we want to bring anti-Morconi additions, Br always add from less substituted side, from second side. So we have made this fragment, and this fragment was second last fragment. We have made this second last fragment. Now do Hoffman eliminations. Hoffman eliminations mean unsubstituted alkene we have to make. So for unsubstituted alkene and Hoffman elimination, always keep in mind tertiary butoxide reagent is used. So this tertiary butoxide reagent will give unsubstituted alkene. And now this fragment is, we have synthesized this fragment.